This video is on probability of using tree diagrams. So we're going to do two questions here and draw a tree diagram for both of them. The first is a coin is flipped 3 times. How many combinations are possible? The first thing we should notice here is that if we're flipping a coin, then that means that this coin has 2 sides. For the purpose of this video, we're just going to say this is heads and this is tails. And it is flipped 3 times. So let's go ahead and draw that in our tree diagram. If I flip it once, I have the option of getting either heads or tails. If I flip it twice, I can then flip it heads or tails from here. If I got tails the first time, I could get heads or tails the second time. Then if I flip it a third time, if I got heads, then I could still get heads again, or I could get tails. If I got heads, then tails, I could still get heads again, or I could get tails. And then the same thing down here. I could still get heads or tails each time, no matter what my outcome was prior. So then when it says how many outcomes are in this sample space, for outcomes, we're going to look at the very last row of this. So this very last row has 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 outcomes in this sample space. The next question, what is the probability of 3 tails? What is the probability of getting 3 tails? So the first thing I noticed is that this is heads, heads, heads. I can't go there. Heads, tails, I can't go there because it starts with a head. So I have to follow this branch out because I have 1 tails here. Then I have to get another tails. And then I have to get another tails. And this is the only way that I can do that out of my sample space of 8. So the probability is 1 out of the 8 different possibilities. When it says, what is the probability of exactly 2 tails? So the probability of exactly 2 tails. So I could get heads first. I could go here. And then I would have to get tails, and then I'd have to get tails again. So this is 1. If I got tails first, I could get heads, and then I could get tails again. So this is 1 option. If I got tails first, I could get tails a second time, and then I could get heads because it has exactly 2, not more than 2. So I have 1, 2, 3 possibilities out of my 8 total. So this would be 3 out of 8 is the probability of getting exactly 2 tails. Next question. Miss Hunter is getting dressed and has the option to wear a gray or blue t-shirt and jeans, black pants, or a skirt. How many outcomes are in this sample space? So let's go ahead and just draw our tree diagram at first. I'm going to wear a top and bottom. So my options for my tops are either gray or blue. So let's start there. I could either put on a gray or a blue t-shirt. And I'm just going to abbreviate this. I could say gray or blue. And then after that, I have to choose out of 3 bottoms. So I could have jeans, black pants, or a skirt. So I could put on a gray t-shirt, and then I could put on jeans. I could put on black pants with that, or I could put on a skirt with that. Or I started with the blue t-shirt, and then I could put on jeans with that. I could put on black pants with that, and then I could put on a skirt with that. So how many outcomes are in this sample space? This would be a really good time to pause the video and go ahead and try these next 3 questions on your own. When it asks how many outcomes, remember, we're going to make sure and look at the very last row. So in this case, I have 1, 2, 3, 4, 5, 6 options here. So there could be 6 options here. The other shortcut way of doing this is that, remember, we have 2 tops and 3 bottoms. Well, 2 times 3 is also going to be equal to 6. So sometimes when we want to draw out a tree diagram and there's, let's say, 17 choices of a shirt, we're not going to want to draw that. We're going to want to use the shortcut method. What is the probability of wearing jeans? So what is the probability of wearing jeans? Okay, well, I could wear a gray t-shirt and jeans, so that would work. I could also wear a blue t-shirt and jeans. That would work. So my probability is 2 options out of my 6 total, but 2 out of 6 can be reduced to 1/3. So the probability is 1/3 that I will wear jeans. What is the probability of wearing a blue t-shirt and black pants? So I have to wear a blue t-shirt and black pants. So, okay, you might be able to already answer this. But if we're using our tree diagram, I have to go this way. And then I have to go this way. And this is the only option. So this would be 1/6 would be my probability. So that's an overview of probability using tree diagrams. Remember, you can always go back and try these on your own, or go back and do the lesson problems or homework problems again if you need more practice.